Right folks, well we've got a realistic TRC1001 here from the trade in Sheffield, and I've got two. He's got a jammed element on a set. On another one he can't get the final element out, not the top one, not the weak little top one, but the bottom one. So I might take out the ferrite rod and put it in our ultrasonic cleaner for 20 minutes and have it at quite a high temperature. And I think between the heat and the ultrasonic we'll have got isopropyl alcohol in that, and I think probably 20 minutes in that and it will be clear. I would think it's got a bit of water down it and it's corroded. Right, so it's realistic TRC1001 288654, and it is, if I put Sheffield down we know who it is. Oh, so his little note, no transmit audio, a broken core on T1, intermittent transmit and receive, possible dry joint. Well, that's absolutely right, because they do. Double-sided board, they're not plated through, they're just in, the tracks are I think they are on these. I think they're kind of riveted through. I remember a relative passing away in Sheffield and lived quite high up, and I was having to do some executor work on the estate, and it was one of those houses where the living room is on the first floor. People in America will have to realise that first floor means upstairs. It's ground floor, first floor, second floor, and so on. Not like in America where it's first floor, second floor, and we have ground floor. So that's the complication. Let's put the soldering iron on. Anyway, I put one of these on the windowsill of the living room, which was upstairs, and it's quite high up property. And Mr. Chippy called through from, I think it was Barnsley, 16 miles away. I had hand portable from one of these to him in the car, 16 miles. As long as you don't poke the ceiling out with 1.5 metre of telescopic aerial. So I always say, if you want hand portables, all these new ones work great, but they haven't got the range because they don't have the telescopic aerial. These range boost side panels are not a gimmick. These connect you to chassis. Your body becomes part of the ground plane. Makes a massive difference. And once Realistic went away from having the metal side panels like on the 1007, so 1001, the 1005 with LCD display, there's the same chassis, but the LCD display has a subboard. And so you got the range boost side panels. And then when they moved over to the 1007, which was a bit more squat, you'd lost the range because they hadn't got the range boost side panels. So the very thing they were trying to sell you as being a thing, they discontinued. And that, I mean, these were $119.99 back in 1981, a lot of money. But there's still room for very expensive radios. Take the President Randy, that's a very expensive radio, it works well. And we've done, you know, we have this Joe Pix one on the bench, and when we did the range test, that this is still 4 watt set allegedly, and you'll have seen the video we've done on that. But the President Randy 3 has got a 1 mile range improvement on what that Joe Pix one, and this Joe Pix one works better than the Midland 42. And it's all down to aerial efficiency, and that Thunderpole one nearly works as well as the Randy 3, but not quite. I know there's one or two other good ones, but you know, by all means, buy one of those. Great. But if you want real good range, you need one of these as well. I know if you're camping, you can't have something chunky like this, but if you want the range, it's the way it's done. So there's nothing for it. You have to take this screen plate off. That's how it is, because that's where the dry joints are. I'm going to pause the video and take the screen plate off. So without powering it up, we'll look for dry joints first. Beauty there is it's through one of the print things. As I was saying, you've got these printed these holes which go through the board. So there's one. So I'll do what I can see, and then we've got this coil to change. That's why I sent it in, because we've got a scrapper. Potentially there's one there. Yeah. So I'm just going to do those. I'm just looking for these rivets. They are the troublesome bit. Alright, let's look at the other side. I might be tempted to take that off, we'll see. So you've got there, there and there to play up for a start. There's one down there. There's one down there. So I'll just do some of these top side ones. Can't get down to that one without damaging the wiring, so we won't damage the wiring. Right, well that'll do for a start. We'll power it up. I've got a bit of a flimsy power lead for these, which should be okay because they usually draw under 1 amp. We've got because we're just doing a realistic, let's put that camera back in its normal position. Because we were doing a realistic, I've got the realistic mic on the bench. We can use the external mic socket. He says he's got no transmitted audio, so the switch in there can play up, and of course, as he suggests, the switch here can play up. So I've got to determine whether we've got no audio being transmitted because of the internal arrangement, or whether it works on the external mic. So it's an electric condenser mic, so of course that has to have a polarizing voltage. This is the later model with the power preset, which is much more desirable than the other one. Right, I'll get it powered up. If only I could find... There it is. External power. That's happier. Right, we need external speaker, so plug in the test equipment speaker. And we need test instrument aerial, and then we need an adapter to turn it into phono. Pause the video. So the adapter was exactly where it should be. This is an SO239 to Motorola adapter. This fits in an old-fashioned type of car radio. It also fits in phono. There would be an NC number somewhere, but you know, I'd have to look in a very old catalogue to find that. Okay, well, it's certainly receiving. So we'll just put picture in picture on and go into low power on the test set, and we've got just under 3 watts. I can't see picture. Yes, picture in picture is there, but I can't see any camera showing. That's because that camera switcher isn't on. Still got no picture. Right, well, I can't deal with that at the moment, so I'll have to carry on. So the check here is what it's doing, and I've probably fixed it anyway, apart from the coil he wants doing. So on channel 20 it's 2.8 watts. Channel 40, 2.8 watts. By the way, these are 3.5 watt sets. Don't think for a moment they're 4, because it doesn't make any difference, but it draws a lot more current. It's actually 2.7 on that. Low power. Back to channel 20. Low power is preset on these, and this one's 150 milliwatts. And the transmit current, if we go back to full power, is 788 milliamps. So let's see if we can got any deviation. Wallow, we have. So put the hand portable on, and hopefully we can get ourselves some feedback. Testing 1 2, testing 1 2, testing 1 2. Testing 1 2, testing 1 2. Deviation, you never really get 2.2 out of these. It's usually around about 1.9. We'll just see what it is on this test set. Wallow, it's about 1.9. And we'll just test it with an external microphone. Testing 1 2. Wallow. It's just a little tiny bit more with 2 there. So we're going to say 1.9. We don't do the VCO on it because it's working on all 40 channels. And the frequency, test set's been on all day, it is now 27.79123, so it's spot on. And the RF meter, it does have one. Well, it's battery meter. Doesn't have one of those. Bat meter, okay. Doesn't have one of those. That's working. Those are working. That's working. Doesn't have that. That's working. We don't know about speakers. Let's have a look at receive. I'll come back to this tomorrow. Whoa, look at this broken print. My goodness. That wants I think that wants some araldite doing. I didn't spot that from the other side. Just zoom in. Can you see how that is on an angle? So it's been, looks like it's been dropped on its aerial. That's why the aerial's a bit more in than it ought to be. So I think what our customer needs to do is to mix some epoxy resin and flood that area with epoxy resin to stabilise that. I wouldn't recommend trying to push it out or anything. Wow, I've seen the board totally broken away on one of these before now. Right, anyway, receive. We never get what you'd expect because of this adapter tree. So you just have to take my word for it whilst the switcher doesn't. I'll just check the switcher's plugged in at this end, just in case. Now, the problem isn't that the problem with the other camera. We've got the overhead cameras on the console in front of me, and then the other 3 cameras are switched by that remote control. And for some reason, there's nothing coming through the SVHS to whatever it's called, HDMI adapter. Right, receive at the moment. Actually, it's working very well. It's 0.9, which, considering it's going through all these adapters, is fine. 0.82 and 20 dB. Actually, does do it. 0.64. Sorry, two dead. I don't know if squelch is going to be what we expect. It's a hand portable at the end of the day. Full squelch. It's non-adjustable. It's I'll soon tell you. It's 10 microvolts on full. This wouldn't be much good as a mobile, though you can use them, of course, as a mobile. Or in a city, it wouldn't be much use as a mobile. Set the squelch threshold. 1.4. If I can get something more out of the receiver, that might improve, especially if it's the IF. So that's probably where we're going to leave it today. We've just done the initial exploration. He needs me to change. There's a broken core on transformer 1 in the receiver. So let's just see where transformer 1 is. Yeah, it's there, right. If I remember rightly, that's the do not touch spectrum analyzer one. Yep. We might have to find one out of a scrap set. So I'll come back to this tomorrow, but at least it's basically working and it is transmitting audio. You see, he's saying no transmit audio, but there is, and sometimes intermittent TX and RX. I think we've covered the drive joints with what I said. So see you tomorrow. Right, I've got the camera switcher to come back on. So I've got picture in picture back. So we'll go through a retune on this. Better check for continuity. Telescopic aerial. Yep. Got there in the end. We'll put that back on for now. Obviously I've got the screen plate to do. Keep the PTT out for now. Right, so aerial back into the receptacle there. Power back into power. Power supply on. Select 12 volts. Just check exactly what volts. So it's 12.5. I'm going to put these up to 12.5. Just like that. Want the extension speaker back in. Test instrument one, that is. and we'll do it with the extension mic. There we go. So the manufacturer says it needs to achieve at least 3 watts. Let's go through the alignment. We're not going to do the PLL alignment because we don't need to. It's working on channel 140. That's not what it's in for service for. And we do have additional fees, so don't need to incur costs to the customer which are unnecessary. But I've covered it loads of times, and if you need to see how the VCO is done, the test points and so on, I've covered it loads of times. So I'll put the squelch on. We're going to start with transmit, and it's L5, T6, T7, T8, L8, L9. So is there a little chart as to where those are? Yeah, so I've got this, I'll just kind of move that so you can see. So it says L5, that one, and then T6, 7 and 8, so T6, 7 and 8. So we start there, 6, 7 and 8, and L8 and L9. We need to put the power preset to full, if it isn't already. And I'm going to need an appropriate trimming tool. I'm sure it's the white one for these. Yeah. Sometimes you need to remove the snowflake stuff to be able to shift them because they've got to stop them moving. Right. Going for transmit. So now we're at 12.5 volts. We've got 3.3 watts. Just go for this one first. That is in the centre. That's in the correct position. That is. He's probably done all this, but I just need to verify. Just check the power preset. I'll go out of transmit, so it's got the opportunity to cool down. I've gone and left my screwdriver, which I was using to apply the epoxy resin. I've gone and left it in the kitchen when I was cleaning it off. It was at full. So we're doing 3.4 watts. Remember, it's a 3.5 watt set, so there's going to be losses in here, so that's fine. Back into transmit. We'll start making some notes. So we took these yesterday, but I did it at 12 volts, so it came up straight. I've only really gained 0.1, so 3.4. And channel 40, 3.4, channel 1, 3.35. Current consumption on channel 20 is now 908. Right, and low power is now 1.8 watts, 1.8, 180 milliwatts. So we look at what the thing says. Nominal is 3.5 watts. The limit spec is 3 to 4. So we're very, very close to nominal. And if you read it on any other test set, it'd be more than that anyway. It's just that this doesn't read any interference out of band. Low power, supposed to be 250 milliwatts. In fact, it's supposed to be 400 milliwatts because the government say so. But there you go, they've interpreted it differently. But the limit spec is 0.1 to 0.4. So we're well within there. Now, the absolute maximum they want deviation to ever be is 2, and 1.5 is the minimum acceptable. So we're going to go over to the other test set behind me. I'll just see what it says on here, but we have to take this test set on deviation with a pinch of salt, with it's got some duff capacitors in it. Sometimes it's spot on, and most of the time it isn't. So, let's retune this. Wow, it actually says 2.4, and that is possible. Strange AGC on these, so they have a louder peak for about a quarter of a second, like Bannerton Route 66s do. Right, so let's see what the other test set says. Wow. It's not very happy. I don't think it's been on long enough. I think it's only been on 5 minutes. Give it another go. Wow. Now we'll come back to this in 10 minutes. Yeah, it's reading 2. So we only got, I think we only got the one preset in these. So that's deviation. Wow. We actually got 2.5 absolute peak there. So that's good. Right, we'll go back to the other test set. See how that compares. Wow, it's about 2.5. It's reading right today. So out of interest, we'll go into the internal microphone. Wow, about the same. Good. Well, that sorted that out, hasn't it? Right, on to the receiver. So 2779125 on the signal. I'll tell you what, let's check it's on frequency. Back into transmit. 2779123, spot on, isn't it? And again, it's under that can. We don't need to do that. It's been done. So we'll put the signal generator up. 2779125. So we'll have it exactly as it is on the transmit. So of course, because I've changed that coil, it's now going to be different. So the sensible thing would be to alter that first, because normally we'd do the detector. But because we know it's being altered, that takes us to 3 microvolts. Just change the scale on the test set. Now we'll go and do the detector. So 100 microvolts. Wrong one. Enough volume for a meaningful trace. It's going to be that one. Yep, that's right. Back to the cyanide meter. Just make sure we're doing all the right ones. So transformer 4 is the detector, and then 1, 2, 3 and 5. One, 2, 3, 5. Done one. Turn the signal down a bit more. 2. 3. 5. Right, it's time to put the screen plates on. And then we can see what we're actually getting and probably do a little touching up on it. I'll just pause the video. Right, an hour later we are back. I did the isopropyl alcohol, and we've probably got a cleaner board than it had when it even left the factory. I'm just going to look very closely at that soldering. We did the tune-up and the sensitivity was considerably less than it was on the initial test, and I want to demonstrate to you why that is. It's not because the radio's fixed worse, it's because we've actually connected the rod antenna. So once we connect the rod antenna, it's kind of robbing the signal, and this is why we always have poor sensitivity results on these sets. It doesn't mean that they're poor sensitivity, because they're not. Just do this. Right, screen plate. When I can remember where it goes. It's there. I've got it the wrong way around, haven't I? some of the damage for the printed circuit board is just here, so you're just not going to see it because of the screen plate. Yeah, I reckon we're there. So I'm not going to put that back on so I can demonstrate this to you. I really shouldn't be messing about with the rod antenna. We've lost the wire now to the little switch. That's been flexed so many times it's snapped off. I think we'll wait till we've got a bit more of it together. So let's get it powered back up. I won't bother plugging the mic in, we're just going to be doing receive. Power it back on. Let's get the aerial connected, as in to the test equipment. So let's look at the sensitivity. I've got the synod meter on. Let's see exactly. Look, I've got it on 12. I'll just see if we can do it on the 1 scale. It's easy to read off. I can't now. I'm on the 3 scale. So just see what we've got. I now have 2.4 microvolts for 12 dB. Now what we're going to do is disconnect the rod antenna. So the last thing I really want to be doing is this, but I want to demonstrate why. So that's the rod antenna removed. So now all we've got dragging on the aerial connector is just that little bit. Let's see what happens now. Now look at the meter straight away. We're now at 20 dB, so I can reduce the signal generator. And we're back to exactly as it was when we started off. We're back to 0.9. So you know what, I'm going to tune it with the rod antenna disconnected, just to see whether we can get that extra bit of something. I'm going to hold on to the chassis. Look, we can. Let's drop off a signal a bit. And then wherever my other tool is, there we go. So, let's see what we've got. I will hold on to the case because that's part of it. So we've now got 0.75 with the rod disconnected. Not 0.75 for 10 dB, 0.6, and for 20 it's 2.4. So, see whether we can improve that. We'll just do that detector again. Now we've disconnected the rod antenna. Not that loud. Let's read off 20 again. Two. So I should have realised it was so good when we initially tested it that the antenna had got to be disconnected. Now then, let's put that back and look again. So it's not really less sensitive, it's just not reading right. And then what I'm going to do, I'm going to put hot glue between the rod antenna and the chassis so that there's more of the support here than there is on that bottom point which we've epoxy resined. So once again we can put it back on the signal generator. Let's look at those results. Back to the cyanide meter. 12 dB. If I hold on to it as I'm doing a fair test, it's 1.8 microvolts. So that's why. So we'll come back in about an hour. I'll get this glued. I just want you to see why I'm doing these like this. But you know what? I think it's worthwhile taking the bottom off and getting that extra ounce of tuning, which we can do by not having the load being upset by having the rod antenna still connected. Okay, so we're back. So just to be clear, having spotted the crack in the board, it wasn't quite severed, but the bracket was bent down. Epoxy resined it from this side. On this side, epoxy resined it. But before I did that, I put a link in so that the rod antenna was actually connected. Just put the other glasses on so I can see what I'm talking about. So we've done the tune-up, we've done the dry joints, we've had the screen plate out, put it back, and now what I've just done, to give this rod support, we've used the hot glue gun between here and the rod and the chassis. So the idea being that when you pull the rod antenna out, this is giving it absolute support, so it's not, normally it's supported by the printed circuit board, and it's now going to hopefully have full support because of doing the hot glue there. So I think that's the best anybody could do there, because at the end of the day the printed circuit board's broken. So we'll put that lid back on. So that's it, we're in. And then all we have to do is to put all the screws back, and we'll just check the alignment in the squelch operation. So I'll just be screwing this together. I'll solder the wires to the PTT's light illuminated button. Right folks, we're all put back together and done the PTT. So when you press the little black button, the display's supposed to come on. It does. And fade back out. So when you turn the channel selector switch, it comes on, stays on for a second, or when you press the black button, the same applies. So that's that. So we're all done. I will just look at we'll just see where the squelch is, because I've done a retune, but there's no squelch adjustment, so you get what you're given. Where we were before was 10 microvolts. So if it was a mobile, that would be a bit wishy-washy, but it's at the end of the day, it's unportable. So put the squelch to full, and we'll put the attenuator up on the inset picture, and signal generator 310. Of course, this is with the rod antenna connected, and because it wasn't before, was it? So we actually have a better squelch figure because it's now 16, but that's simply because the rod antenna is now connected. Sensitivity. Set the squelch. And on the face of it, because the rod antenna is now connected, it's 5.1. Not, yeah. Which isn't the case, because it's the way the rod antenna is interfering. So here we are done. We'll do an on-the-air test. I think just before we do that, what I'm going to do, I'm just going to pull up the telescopic. I didn't say that, did I? Pull up the telescopic aerial and call Mr. Chippy. Now, whether or not he hears me, we'll go over onto channel 31, and it might come over the tannoy system. So I'll tell you what, we'll plug in the external mic. We'll pull up the rod antenna. Try not to tickle the camera. This will prove, you see, whether that's connected, because otherwise he wouldn't hear me if we were just on the dummy load. Tango 21, Mr. Chippy, can you call me back on the base station for a test? Oh, I've not got the speaker plugged in. Sorry about that, I haven't got the speaker plugged in.
Yeah, roger, I'm receiving okay anyway.
I'm just going to switch to low power. Testing 1, 2, 3 on low power.
Yeah, no problem.
I'm just proving the rod antenna is connected, thank you. There we go. Right, back to full power, put the rod antenna down. Always put these from the bottom down, not like they did on films from the top. Might look impressive. Right, we'll put the top lid on. Just re-tin these. You know what, the speaker in this is about the same size as you get in a mobile today. So these are well worth this kind of time. We've not had to spend anything on parts. Theoretically we may have had to get a coil off a scrap set, but I was able to recover it. So there we are, done. You notice I avoided that because that needs setting up on the spectrum analyzer, and there's an extra fee of course for that, so we don't need to do that. It looks fine. This is what this is part of the scratchy corner test. You know how we go, if he can hear us going past raw speed level crossing a petrol station, I know it's all on 27 megs. So we will put that back. I like to put the back screw in first. We never test these things on batteries when the customer repairs. Might do for an end user. Again, there'd be a different fee, because at the end of the day, it's a trade customer, and if there's something wrong with the battery compartment, well, they can sort it out. But it looks clean. I think these could be better than the 1005. In the 1005 with the LCD display can have issues with the dry joints on the display board, but they're the same chassis. They're crystal filtered as standard. There's a 10.695 crystal filter. So there you go. So the way you're supposed to hold these is with the strap and holding onto these range boost side panels. And there you go. It works super. I'll turn the signal generator off. I can hear it in the background. Turn picture in picture off. And we'll go through the channels. First of all, put the squelch on. Go through, put its own speaker on. Yep. And we'll put the aerial into the Motorola adapter. One niner Roger. Bit of something there. There we go. And just as a final test, I just put my walkie-talkie on. I left it on last night, and it was beeping away with a flat battery by this morning. You like that? Just back on channel 20, testing 1 2, testing 1 2, and then on its own aerial. On its own mic, testing 1 2. Brilliant. Thanks for watching the 1981 Realistic TRC1001 late version. Brilliant set.